Hello all. In this lecture we will see about indexing structures for files. So we have already seen organization of files like unordered files, ordered files and hash files. Now we will see how to index those files so that searching, sorting, everything will be much more easier and faster. So this is the outline of this lecture. We'll see what introduction, then we'll see primary indexing, clustering indexing, and secondary indexing. So these indexes are used to speed up record retrieval in response to certain search conditions. So when we want to search something, if we have an index, then that record retrieval will be much more faster. So index structure provides secondary access paths. So it is an alternative path to access those record. Okay, from the disk, from the hard disk. So any field can be used to create an index. So there are different fields in the record like name, social security number, phone number. So you can use any field as to create this index. We call them as indexing field. And we can have multiple indexes also. So instead of a single index, we can create indexes on multiple fields like for one index for name, another index for phone number, another index for university register number. Like that, we can create multiple indexes, and most indexes are based on ordered files. So we create indexes based on ordered files. Okay, so all the disk will be ordered, all the files in the disk will be ordered, and we create index for that. So it is not always the case. Most cases it will be indexed ordered files, and we can have tree data structures also to organize this index. We will learn about this tree data structure in the next lecture. So first we will see types of single level ordered indexes. So types of single level ordered indexes. So this is similar to index in a textbook. So if we see the back side of a textbook, there is an index. So in that index, everything will be in the alphabetical order. So if we want to search uh, name schema, so you have to search for S and you will get schema, and in schema you will see the page number. So you can simply refer that page number, you will get it. You will get the details about schema. So there is an index at the back side of that page. So it is an ordered index. So it is similar to the that is the textbook. Okay. So indexing field we call it as it can be any attribute. We call whatever field we use for indexing is known as the indexing field. It can be any attribute. So index stores each value of the index field with list of pointers to all disk blocks that contain records with that field value. So in the case of textbook, behind we have different indexes. We can call it as index values. The different words that are sorted in the alphabetical order will represent the value of the index field. And we have page number. Page number will be the pointer, that can be considered as a pointer to the disk block. So by searching the index, we get the address of the disk block where the actual content is there. So if we want to search Oracle, so you have to search in the behind, you can see the index and you will go for Oracle, and page number will be listed as 225. So in 225, it will contain the actual record. Okay. So index will store each value of the index field with list of pointers to all the disk blocks. So it may be several disk blocks. So if you see in backside, Oracle may be located in different pages. So you can see 225 comma 300, like that. There will be different page numbers. So all the pointers to all the disk blocks will be mentioned in the index value. So values in index are ordered. So if you see the backside, it is ordered. It is in alphabetical order. Similarly, the index is also ordered. So all the index values will be ordered. So we have three types of single level ordered indexes. One is primary index, second is clustering index, and third is secondary index. In primary index, it is specified on the ordering key field of ordered file of records. We will see in detail. And the clustering index, it is used if numerous records can have the same value for the ordering field. Okay, we'll see examples and you will understand what is the secondary and all. Then we have secondary index. It can be specified for any non-ordering field. So don't worry about all these three indexes. We will see each one separately. Okay, data file can have several secondary indexes also. We'll see all this. So first we will see primary indexes. Okay, primary indexes. So it is an ordered file with two fields. So indexing, primary index is a file. It is a file. So in that file, we have two fields each. Okay, we have two fields. The first field will be a primary key. Since primary indexing is used to keep the keys of or the indexes of key values, the candidate keys. Any of the candidate keys can be used for primary indexes. So the first or the primary index is a file which consists of two fields. First field is the primary key and second field is of course the pointer to that particular block. So if we want to search register number with TCR 19 some CS21, so that is the key field, and for that key field we have a pointer also. That address will also be there, which specifies which block that record is there, that student's details are there. So it is stored in the index file. So it is stored in the index file. So these two fields are stored in the index file. So it will be in this pair k of I comma x. So it can be replaced by x also. Okay, it is not matter. So x denotes x can be anything. So x may be a physical address of a block. Okay, or x may be a record address made up of a block address and a record ID, or x may be a logical address of the block or the record within the file and is a relative number that would be mapped to a physical address. So it will be in this pair. This primary index file will be in this pair, primary key comma pointer to this block, or pi can be replaced with x, and x can be anything. So x can be a physical address of a block, or it can be a record address, or it can be a logical address. You have learned about virtual addressing, logical addresses in operating system. So it can be a logical address of the block also. Okay, so all those displacement, everything will be calculated and you will get the actual record in that. Okay, so this is an example of primary indexing. So here the index we use is the name. Name is the primary index that is being used. So a name is already ordered. So we have to assume that every employee will have or every student will have unique name. There is no duplicate names. That is why we are taking a name as a key field. So we have to assume that name is a primary key here or name is a candidate key here. Everybody has a unique name. So that is the assumption we have made in this example. So we have this index file. So this is the index file. This is the index file. So index file will consist of ki comma pi entries. So ki is the key and we have a block pointer also. We have a block pointer where that will belong to. So Aaron, it belongs to, if we want to search Aaron to Adams, it will be in this block. If we want to search Adams, it will be in this block. And similarly Alexander, it will be in this block. Like that, every for every key there is not a block point. There is no block pointer. So we will see about this later. So if we see this from Aaron to Adams, there are different several names that will be there, like Abbott, Acosta, like that. There will be different names. So from Aaron to Adams, everything will be in block 1. From Adams to Alexander, everything will be in block 2. It is like this. Okay. So this is known as primary indexing. So this index file is known as primary index file, and this is actually block anchor primary key value. We call this as block anchor because Aaron is considered as a block anchor. It is the first value or the first record in that block, or Adams John is another block anchor. This is the first value in that block. Similarly, this Arnold Mac is the block anchor of this block. So this is known as block anchor. Okay, block anchor. So this is known as anchor record. This Aaron Aids is known as anchor record. Okay, or else we can call it as block anchor. So one index entry in the index field for each block in the data file. So we have only block addresses. For every block we have one address. For this block we have one address. For this block we have one address. So one index entry in the index file for each block in the data file. So first record we call it as anchor record, or else we can call it as block anchor. Indexes may be dense or sparse index. So we will see what is dense and sparse. So dense index has an index entry for every search key field in the key value in the data file. But in this case it is not dense, because for every data file we do not have an index. So this is actually sparse. Okay, dense index means has an index entry for every search key value in the data file, and sparse index has entries only for some search values. Okay, so in the previous example it is a sparse index because we do not have indexes for all the data files. We have only indexes for a few data files. So we are storing only the anchor records address in the index file. So this is sparse index. Okay, so dense index will have entry for every search key value. So this is sparse index. So major problem with this primary key indexing is with insertion and deletion of records. Insertion and deletion of records. So when we try to insert an element, it will be a problem because it is ordered. If you see this, it is ordered. So when we try to insert some element into this block, if we want to insert some name like Adya, so it should be inserted in the first block itself. So what the problem is, this block is already full. So we need to move something outside, then only we can insert that new record. So that is a problem here. Since it is ordered, insertion and deletion of records is a problem here. So one way is to move records around and change those index values. Okay, we have to move everything. So we have to move records around and change all those index values. So it is a problem here. So there are different solutions. One is use unordered overflow file. So we have already seen when we studied indexing, we have seen we will have an overflow file, and if some overflow occurs, if one block is full, if you want to insert some new item, if that block is full, then you have an overflow file, in that you will insert. Okay, or we can use linked list for this overflow records. So these are the two methods to solve this problem, for insertion problem. Then the second type of indexing, we call it as clustering index. So if the file records are physically ordered on a non-key field, non-key field means which is not a candidate key field, then we do not have a distinct value for each record. For example, if we are sorting the students based on department, if we are storing indexes of department, department is not unique. So in a department there might be 300 students. Okay, so we create indexes for non-key values. Non-key means like department. So department is a non-key value. So department CSC we have 300 students. Mechanical we have 500 students. Like that, for every department there will be several number of students. It is not unique. Okay. So here the clustering field, it is file records are physically ordered on a non-key field without a distinct value for each record. So here also ordered file clustering index will consist of an ordered file with two fields. It is similar to primary index, same type as clustering field, and we have a disk block pointer. Instead of the key field here, we have a clustering field and a disk block pointer. In the previous case, we have a key, comma, disk block pointer. Here it is not key, it is any clustering field. It can be any field. it is non-dense and it is or it can be called as sparse, because we cannot store for each and every entry we will not store. So that is why it is known as non-dense or sparse. So this is an example for clustering index based on the department number of employee. It is a non-key field. Department number is not unique for a particular employee. So department number 1, there will be several employees working on that department. So we have 3 employees. Department number 2, we have 2 employees. Similarly, for department number 3, we have some 5 employees. Okay. So here we are storing based on clustering field. So this is the clustered index. This is cluster index. So we will store in the order cluster field value comma block pointer. So this will give the address of the blocks. So 1 and 2 is also in the same blocks. 3 is in this block. Okay, 4 in this block, like that. So this is based on, this is clustering index. So this is of the order, this is not ki actually, this is actually clustering field value. So this is not unique, and this is not, this is sparse index because for all the data files we do not have indexes. We create data files only for some of the entries. Okay, and we can have a variation of this. Here we can see it is mixed. We have in a particular block itself we have 1 and 2 department numbers. Here we have 2 and 3. Here we have 3 and 4. So if we want, we can keep this separately like this. So this is another example. The same thing, this is also clustering index. Here in this block, 1 is only in this block. Okay, 2, all the employees with department 2 are in this block, 3 are in this block. If we want another block also, we have a block pointer from this block to another block. So all the particular department number will be in a particular block. Okay, for is this block 5, it is here, and 6 we have in 2 blocks, so it is easier to search. So this is known as clustering index. So it is not based on the primary key, it is based on non-key value. Okay, so this is known as clustering index. Then the third type is known as secondary index. Secondary index. So it provides a secondary means of accessing a data. So it means where there's a primary access already exists, we can have a secondary key also. That is, we have already ordered the data file based on some primary indexing. That is, based on some primary key we have already ordered. Now we can provide a secondary key. Okay. For example, if you take the student details, student database, we might be using a primary indexing based on your university register number. So there is a key, there is an index based on your university register number. Now, if I want to create another key based on your Aadhaar card number, so that is the secondary key. Okay. Or if I want to create a secondary key based on a non-key value like your name, if I want to create, I will create another index based on name. So that is also possible. So that is known as secondary index. So it provides, secondary indexes provide secondary means of accessing a data file. That means there is a primary indexing already existing in that file. So there's some primary access already exists. Now we are providing an additional searching mechanism. So, that primary access will be based on candidate key. It will be based on some of the unique key. So we will be, for example, the student will be using the university register number. We are creating an indexing mechanism. So it is a dense, because primary indexing will be dense, because there will be a entry for every data or every university register number. Okay, so that is why it is known as dense. Or it can be, so we can create the secondary index based on this candidate key or unique key, or based on non-key attribute, that is duplicate keys can be provided. So here secondary index means we are providing additional mechanism. Already we have a primary key and we are providing a secondary key. So that secondary key can be a candidate key. For example, in your student table, it can be the Aadhaar number. So based on Aadhaar number, we provide a second additional access mechanism. Or it can be based on a non-key attribute. For example, name. Name is not unique. The two different students can have same names. So based on name, if you are providing, then it will be a sparse index. So if you are providing secondary index based on some unique key, then it will be dense. And if it is based on non-key attribute, there will be duplicates, so it will be sparse index. So we'll see how to do this. So secondary index also consists of an ordered file with two fields. Like in the previous primary and clustering, we have two fields. One is the indexing field, we call it as ki, and we have a block pointer or record pointer pi. Then it is not physically ordered. There won't be any block anchors. So this is actually a secondary mechanism. So primary, we have already ordered it, and based on this secondary, there is no physical order for that. Okay. So usually need more storage space and longer search time than primary indexing because it is not ordered. This secondary indexing is not at all ordered. We have already ordered based on primary indexing. So this is an additional mechanism for that. So improve search time if arbitrary record is there. We'll see an example, then you'll understand. So this is a secondary index file. This is a secondary index file. Actually, these are the data file, and these data files are already ordered based on some primary key. So if you consider if these are student records, the first field, this is the primary key. So this is the primary key. So if you consider primary key as this is sorted based on university register number. So this is number 1, number 2, number 3, like that. All these are the data files. Now we are providing a secondary key. So this might be your roll number. So this is actually a roll number. So university register number and roll number or admission number. We can take this as secondary key as the admission number. Now we are providing a key for this, no sorry, an index for this secondary key, which is an admission number, and it is unique or it is candidate key also. So this is the thing. So for one, we will have like this. So admission number 1 will be this. Admission number 2 will be pointing to this record. Admission number 3 will be pointing to some other record, like that. Okay. So you have to understand this once more. This is the data file. These are the data files. So this is blank. Actually, this is already ordered. This is already ordered based on some other index, primary index. For example, we have already sorted based on the university register number. Now we are taking a secondary key. Here we are taking it as admission number. Let this be the admission number. So that is also unique. Now we are providing an index to this one. Okay, we are providing an indexing to the admission number. So this is, since this is unique, this admission number is also unique, we will get a dense matrix or dense field, because there will be a pointer for every value. Okay, because this is also unique or this is candidate key. That is what we have written here. So if it is based on some candidate key, then it will be dense. If it is a non-key attribute, so duplicates will be there, then it will be sparse. So we will see another example also. So this is actually, you have to understand, this is data file and this is index file. Even though it seems like a similar to this primary indexing, it is not primary indexing. Primary indexing, it is already there in this data file, and we are providing an secondary index. So we are providing an index for another field. Here we are provided for a key field, which is admission number or Aadhaar number can be used. Okay. Now secondary indexes can be on non-key, non-ordering field also. We have seen a key field. Now it can be for non-key, non-ordering field also. So numerous records in the data file can have the same value. For example, if you want to create an index for name, so name can be may not be unique. Two or three students may have the same name. Okay, so numerous records in the data file can have the same value. So there are different ways to provide this secondary indexing. First option is include duplicate entries with the same key, same KI value. That is first option. So there will be one for each record. Okay. So then it will become a dense index. So the index file will consist of duplicate index entries with same KI. So if we have two same names like Adira and Adira, so one for the first Adira there will be one index, and for the second Adira also there will be second index. Then it will be dense index. Okay. Then the second option, there is another option to provide the second index. We will provide a variable length records for the index entries with a repeating field for the pointer. That is that index file will be variable length. That is for Adira, we will provide two pointers since there are two records for the Adira say that name. Since it is non-key, we have maybe we will have three Adiras in a class. So all for all the Adiras, we will provide one Adira and we will provide three block pointers wherever that blocks are located. Okay. So list of pointers will be like this: pi comma 1, pi comma 2, like that, pi comma 3. So for all the Adira, we will be providing that pointers. Then there is another option, option 3. This is the convenient method to use. What we do is we will keep the index entries themselves at a fixed length and have a single entry for each index field value. And additionally, we create an extra level of indirection to handle the multiple pointers. We will see an example. So here we are indexing based on department number. So department number is not unique, it is non-key value. So when we try to provide a secondary index for this, the problem here is it is not unique. So there will be several threes here. Okay, we have already provided an index based on SSN here. Now we are providing a secondary index based on this department number. So if we see department number 3, we have one, we have a department number 3 here, we have department number 3 here, we have another department number 3, we have here another 3. So what we do is we keep an index file, and in this index file we have only one entry for a particular department. For 3 we have only one entry, but we will keep an indirection index here. So this indirection index will be kept, and in this 3 we can see there are different pointers. So this block will consist of all the pointers through for the 3. So this will point to this block, this will point to this block. Wherever that 3 is there, it will point to all these blocks. So this is known as indirection. That is what is written here. We provide an extra level of indirection to handle multiple pointers. So 3 we have multiple pointers. So here it is here this pointer, it is actually dense because we have entries for everything. So all the pointers, if for all the one, if we can see there are three employees with one, that is why we have three pointers here. So two, we have two employees. This is the first employee, this is another employee. For three, for department number 3, we have five employees. That is why we have five pointers here. Okay, so we have provided an indirection here. Okay, so you have to remember one thing: for secondary indexing, it is an additional index. There is already an index, so we have already provided an index based on SSN. In certain cases, we may have to search based on department, so it is better to keep an index based on department also, but department is not unique here. So what we have to do, we will keep the index file unique. We will keep unique values in the index file, and in between we provide an indirection. So this is also a block. So this block will consist of all the one employee records. So all the pointers, this will point to all the one employee records. This will point to all the two records, two employees, department number 2. This will point to all the department number 3 employees. So this is known as secondary indexing based on non-key value, non-key. So here department is non-key, this is not a candidate key. And this here, it is based on, here this is based on key value. Okay, this is unique. If you see, there is no repetition here. Here it is 9, there is no other 9 here. This is also a key field. Okay. So that's all about secondary indexing. So this is a summary of what you have learned. So uh, so indexing field is key. We call it as primary indexing. Indexing field will be secondary indexing will be a key, or indexing field is non-key, it is clustering index. Indexing field not used for primary indexing will be secondary key. Okay, so this is actually the summary of what you have learned. If we take this primary indexing, and number of index entries will be number of blocks in the data file. It is non-dense, block anchor will be there. Then in the case of clustering, it is number of distinct index field values. Clustering, you know, it is based on some department number, something like. So it is also non-dense. Okay. Then secondary key, based on key number of records in data file, it will be also dense. In secondary non-key, it can be dense or non-dense. It is based on the based on how you use. Maybe used on block. If you are using in that indirection, then it will be non-dense. It will be dense. Okay. So there is no dot block anchors. Only block anchors are available in these two, primary and clustering. So that's all. Thank you.